We discussed question 9 of N-level Pure Mathematics 3, paper 3, in May or June of year 2020. We are given the vertices of a triangle ABC with position vectors OA, OB, and OC. Part A, we need to show that angle ABC is a right angle using a scalar product. For triangle ABC, let's say we have triangle A, B, and C here, and we have vertex A, B, and C. To show that ABC is a right angle, we need to show that this angle is 90 degrees. So we need to find vector AB and vector BC and show that these two vectors are perpendicular using a scalar product. Vector AB is given by vector OB minus vector OA. From the position vectors given, vector OB can be written in the form of 3, 2, and 3, and vector OA is 2, 0, and 5. The component of vector J is 0 for vector OA. Then that gives us 1, 2, and negative 2. And to find vector BC here is vector OC minus vector OB. OC is in the form of 1, 1, 1, and OB is 3, 2, 3. So vector BC is given by negative 2, negative 1, and negative 2. Using a scalar product, so we need to show that the scalar product of vector AB and vector BC must be 0. Then vector AB is perpendicular to vector BC. We have the scalar product of 1, 2, negative 2, and negative 2, negative 1, and negative 2. We multiply the components of I, components of J, components of K, and add. So 1 times negative 2 is negative 2. 2 times negative 1 is negative 2. Minus 2 minus 2 will be a positive 4. And the dot product, the scalar product of vector AB and vector BC is 0. This implies that vector AB is perpendicular to vector BC, which indicates that angle ABC is 90 degrees, which is a right angle. Part B, we need to show that triangle ABC is isosceles. For a right triangle, since angle ABC is a right angle, for a right triangle, it can only be isosceles if the length of AB is the same as the length of BC. So we need to find the length of AB. Then we find the magnitude of vector AB. The magnitude of vector AB is the square root of the sum of squares of all the components. So you have the square of 1, the square of 2, and the square of negative 2. Then that would be 4, 4, 1. So that will give us 3 units for the magnitude of vector AB. And for the magnitude of vector BC, find that is the square root of the sum of squares of negative 2, negative 1, and negative 2. That would give a square root of 9, which is 3 as well. So we continue here. Since the magnitude of vector AB is the same as the magnitude of vector BC, we conclude that AB must be the same as BC. Therefore, triangle ABC is isosceles. Part C. Find the exact length of the perpendicular from the origin to the line through BC. Let's say you have an origin here, and we want to find the exact length of the perpendicular. The origin, you connect the origin O here to parts of BC. Let's say there is a point here. We need to find this distance. In order to do that, we need to find point P, and P is on BC. What we could do is we could find the equation of the line passing through BC first. As long as we can find the vector equation of the line passing through BC, then we can find the coordinates of point P or vector OP. So to find the equation of the line passing through BC, we use the vector equation. We need the coordinate of a fixed point. So we can use either OB or OC here. That is, we can use OC plus lambda times a vector that is parallel to the line through BC. So we could use vector BC. Then in that case, the equation of the line, vector OC is 1, 1, 1, plus lambda vector BC is minus 2, minus 1, minus 2. That gives you the vector equation of a line passing through BC, but that is also the position vector of any points on BC. So instead of writing it this way, we can combine this so that we get 1 minus 2 lambda, and then 1 minus lambda, and 1 minus 2 lambda as well. So that is the position vector of any point on BC. Now let's say vector OP here is the position vector of any point on BC. We consider this to be point P. So we have 1 minus 2 lambda, 1 minus lambda, 1 minus 2 lambda. Any points on BC will have such a position vector, but we need to ensure that vector OP is perpendicular to BC. So we need to find the value of lambda such that OP is perpendicular to BC. OP is perpendicular to BC if and only if the scalar product of vector OP and vector BC is 0. Vector OP is in the form of 1 minus 2 lambda, 1 minus lambda, 1 minus 2 lambda. You need to find the scalar product of this, and vector BC, which is minus 2, minus 1, minus 2. We set this to 0. To find the scalar product, negative 2, we have negative 2 times 1 minus 2 lambda, minus 1, so minus 1 minus lambda, minus 2, 1 minus 2 lambda. This is set to 0. Then we have minus 2 plus 4 lambda, minus 1 plus lambda, minus 2 plus 4 lambda equals 0. Collecting like terms, we have 9 lambda minus 5 equals 0. So lambda is 5/9. Then lambda is 5/9. Vector OP now, you replace lambda with 5/9. Then we have 1 minus 10/9, 1 minus 5/9, 1 minus 10/9. That will give us negative 1/9, 4/9, and negative 1/9. That will give us the position of vector OP, the position vector of point P, such that OP is perpendicular to BC. From here, we need to find the exact length of vector OP. So we find the magnitude of vector OP. That is the positive square root of the sum of squares of all the components. Square this and that as well. And that would give a square root of 1/81, 16/81, and 1/81. So we have square root of 18/81, which can be written as square root of 81 is 9. So we have 1/9 square root of 18. 18 is 9 times 2. So that is 3 square root 2. And then multiply by 1/9. That gives us 1/3 square root 2 units. That would give us the exact length.